Let's see if we can verify this trigonometric identity. So on the left-hand side, this looks more complicated than the right-hand side. So I'm going to start with the left-hand side to begin with. And I tend to replace everything with sines and cosines whenever possible. It's kind of a good starting place for me. So I'm going to bring along the 1 minus cosine squared of x. But I'm also going to go ahead and replace that cotangent using a reciprocal identity. Sorry, not using a reciprocal, using a quotient identity. So we can rewrite that as cosine squared of x over sine squared of x. And I'll go ahead and try to write out any identities that I use along the way to go in between here. This was a quotient identity. All right. The next thing I notice is we do have some squares kind of hanging out along the way here. Whenever you have sine squared or cosine squared, I tend to like to use the Pythagorean identity. So the Pythagorean identity typically goes as cosine squared plus sine squared equals 1. So using this, I notice that first set of parentheses, well, that's pretty similar. It's got a 1 in it. It has a cosine squared. If we do a little bit of rearranging on our Pythagorean identity and just move that cosine squared to the other side, we're going to get sine squared of x equals 1 minus cosine squared of x. So what that tells us is we can replace that first set of parentheses, the 1 minus cosine squared, with sine squared. So I'm going to go ahead and substitute in here. We can say sine squared of x in that first set of parentheses, 1 plus cosine squared of x over sine squared of x. And again, this was the Pythagorean identity that allowed us to change from this first set of parentheses to sine squared of x. All right, next, as we're working on simplifying this down, I'm going to go ahead and just distribute. So I'm going to take the sine squared of x and multiply through to each one of these terms. So a little bit of distributing. But as we distribute, you're going to have that sine squared of x multiplied by 1. So that'll give us sine squared of x. But then be a little bit careful as you multiply sine squared of x by this fraction. You're multiplying by a sine squared of x. We're dividing by a sine squared of x, so that creates a 1. So we're going to be left with cosine squared of x. We're going to be left with that numerator as we distribute the sine squared of x. All right, from here we have sine squared plus cosine squared. Looks like we can go back to our Pythagorean identity one more time when we have sine squared plus cosine squared, or if you reverse this, that's perfectly okay. That's still going to equal 1. So we can say that equals 1. Again, to prove this, we can say, well, that's the Pythagorean identity again. All right, so I hope this helps out. You always want to start with the more difficult looking side. Whenever we have other trigonometric functions, such as the cotangent, what I like to do is always replace those utilizing sines and cosines. That just cuts down the different formulas you have to be aware of and kind of memorize along the way and be really comfortable with. Other than that, it's some algebra and using the Pythagorean identity when we have these squares. Certainly not the only way to go through this problem, but a pretty efficient manner to go through it. Hopefully it made sense as you were watching this video. All right, good luck. Keep practicing.